In Part 5 of Lecture 2, we will look at practical issues in lexical analysis and writing a scanner. We have been largely talking so far about the theoretical underpinnings of lexical analysis, but there are several important practical issues that will arise as we prepare to design a scanner. The first is the issue of the look-ahead character. Case sensitivity, where an upper and lowercase character would be considered two separate characters. How we manage to skip past lead blanks and comments, which can fall one after the other, and how we use that first character to indicate what type of string it is that we're putting together. As humans, we're able to see things in the distance long before we encounter them. This is not an ability that computers really have. So you can't determine if you have reached the end of a lexeme until you actually have done so. And therefore, you have to be prepared to handle the look-ahead character. There are two approaches available. We can start with the look-ahead character and fetch a new one every time the look-ahead character is consumed by the lexeme. In other words, we incorporate in the lexeme its time to get the next character. Or we can work with two functions that manipulate the input stream for us. One to get the next character, and one to unget it, temporarily putting it back in the input stream. This is the function that we will make use of to fetch a character. It has two T's in getC, not to confuse it with the standard function that you find in C. If we're at the end of the file, the first thing that we will do is to return a null byte. By doing so, we've indicated we've reached the end of the file. So if infile.eof is true, what we return is a null byte for that purpose. If the next character that we read is a new line, we'll increment the line count. This will help us when we're printing error messages. However, if it isn't a new line, and it's a letter, we will convert it to lowercase, and that's what we'll return. So everything works a little better this way, and case sensitivity is taken care of. UngetC will return a character to the input stream. It will use putback, and it will also adjust the line number so that we have a proper count as we go along. The only thing that we do here other than decrement the line number is to call the putback method so we can send it back into the input stream. Although lowercase a and capital A are regarded as the same character in the English language, they are represented by different numeric codes, whether we are using ASCII, Unicode, or some other code along the way. For the compiler to be case insensitive, we need to be able to consider these both as the same letter. The easiest way to do this is to convert all letters to the same case, whether we are using uppercase for this purpose or lowercase. Not all programming languages are case insensitive, and these days a very large number of them aren't. C, C++, and Java are examples of this. It's not particularly difficult to skip by lead blank characters. At the same time, it's not difficult to skip by comments. The one problem that we run into, and it's not a major problem, is that we can have lead blanks and then a comment, lead blanks and then comments, and so on, back and forth. What this means is that we have to, in turn, first check for lead blanks, then check for comments, and only when we find something that is not a blank and that is outside of a comment do we actually have what may be the first character of the next token. The method firstChar will skip by both whatever whitespace characters we have and comments until it finds the first non-whitespace character that is outside of a comment. C is the character that we're looking to get, and good char is a Boolean value, initially false. We haven't found a good character yet. If we are at the end of the file, we'll return a marker for the end of the file, so that this way we know that we're going to be returning the token end of file. Having considered the possibility that we have reached the end of file, we now start looking for a non-whitespace character that is outside of a comment. We will keep scanning until we find one or until we reach the end of file. The loop begins while not good char, we haven't found that one yet, and now what we will do is skip past all the white space, keeping in mind at the same time that before we do so we may reach the end of file. If we get past this point, we take a look and see if the character in question is an open brace. In the language for which we are scanning, comments are enclosed in an open and closed brace. This is what we would have in this instance. If what we found is not an open brace, that means we are outside a comment, and we will set good char to true. Now, if what we did find was an open brace marking the beginning of a comment, we now need to skip the comment. We'll keep reading as long as we know we haven't found the end of file marker, and at the same time until we have found the closed brace. If we get to this point and we are at the end of file, we'll return the end of file marker. Otherwise, we will return the first non-whitespace character outside of a comment that we found. One thing beginning programmers learn very quickly is that identifiers, the names that they give to variables, data types, and other things, always begin with a letter or one of a few special characters that we'll use for that purpose. After that first character, they can include digits as well. In most instances, identifiers and reserved words will begin with a letter, then followed by 0 or more letters and or digits. Numbers will always begin with a digit, and operators will always begin with one of several other characters from a set of non-alphanumeric characters. getToken is the main method of the scanner. It has one parameter, a reference, that gives a pointer to the symbol table, something we will talk more about in the next lecture. We're looking for, again, the character C, and we will get that look-ahead character, and if it is the marker for the end of file, that is the token that we will return. We now get our look-ahead token. If it happens to be a letter, we will call a method called scanWord. If it is a digit, we'll call a method called scanNum. If it's something else, we'll call a method called scanUp. What we're going to do is we will return the token that we get back from one of these methods depending on what the nature of the character in question is. Once we know that the first character is a letter, we're going to have it continue to read characters and concatenate them to the lexeme until we encounter a character other than a letter or a digit. The resulting lexeme may not be in the symbol table. If that is the case, it must be a new identifier that we have not seen yet. Please keep in mind that we are going to pre-install reserved words in the symbol table, so if it's something that we have run into that's not there already, it cannot be a reserved word. We enter the method scanWord knowing that C is a letter. The first thing that we'll do is we will put this at the beginning of the lexeme, and as long as the new look-ahead is not the end-of-file marker, and as long as it is either a letter or a digit, we will concatenate it into the lexeme that we're building. After every time we do this, we need to fetch the next look-ahead. Having gotten past the first letter and alphanumeric characters following it, we've reached the end of the lexeme, so we will put a null byte there. Keep in mind, again, these are C-style strings. We'll call unget to take the look-ahead back into the input stream, and then get the next look-ahead. This may seem counterintuitive, But the reason that we do this is that between the end of the lexeme and the beginning of the next one, there may be one or more blanks and one or more comments. We now will call the method installName part of the symbol table, and if our character is already there, we will return the token class associated with it. If it is not actually there already, we will have installed it. We will set its attributes so that its semantic type is unknown, but its token is identifier, and that's what we will return. If the look-ahead character was a digit, then we're going to be reading a numeric literal, and we will concatenate any digits that follow until we encounter a non-digit. If that non-digit is a period, it will concatenate this to the lexeme and continue reading characters until it encounters another non-digit. If it's an E, that means there's going to be an exponent to read. The token associated with the lexeme will either be number or the type of the number. In the method scanNum, again, we have the look-ahead character and a reference to where this is going to be in the symbol table. Integer value is going to be an integer as opposed to R value, which is a float, because the value of the literal itself is something we'll want to keep. Is it real is going to initially be false. We're not going to assume that before the fact. And we have, of course, a string to read in the lexeme. The first thing that we do is begin the lexeme with the look-ahead character. And as long as there are additional look-ahead characters and not the end-of-file marker, and as long as what we're reading is a digit, we will concatenate that digit to the string and get the next look-ahead. If that look-ahead that was not a digit is a period, that means it's a decimal point and there's a fractional part to the number. Is it real is now true. We concatenate the decimal point to the lexeme, and as long as we get look-aheads that are not the end-of-file marker, and they are a digit, we will concatenate them to the lexeme and get the next look-ahead. At the end of all of this, we are going to add a null byte to terminate the string, and we will then get the next look-ahead for the next lexeme. We're not going to look for E because this particular language does not include numbers with exponents. If there is no fractional part, then what we have clearly is an integer literal constant. If there is one, it is a real literal constant. But first let's see if it's in the symbol table. We call installName, and if this returns true, it is already there, and we return the token associated with it. If not, let's see if it's real. If it is, we will install its attribute as the token being constant, semantic type being unknown. Then afterwards, we will set its data type as real and its semantic type as literal. We need to be able to install the value, so we will convert the string into a floating point number, and we will save that in the symbol table and return the appropriate token. On the other hand, if it is an integer literal, we will still set its attribute as semantic type unknown and token being constant. We will, however, install the data type of integer as we are giving it the semantic type of literal. We now find the integer value and we set that in the symbol table. Then we return the appropriate token. At this point, in either case, what we will do is return the look-ahead, and then we will return the appropriate token. If the first character is not a letter, and if the first character is not a digit, then there are a few things that the lexeme could represent. It could be an operator, it could be a literal, either a character or a string literal. In scanning an operator, we should be cognizant of how many characters it may maintain. We may wish to hand code the token that will be returned by the symbol table. In scanning a literal, we'll read characters until we encounter the appropriate closing quotation mark.